You know, whenever we try to solve something really big, really complex, we tend to fall into one of two camps. There are the architects, who build from a grand master plan, and then there are the archaeologists, who discover the truth from the ground up. This tension, this push and pull between designing and discovering, it's a hidden pattern that shows up absolutely everywhere, from our DNA to our digital worlds. Let's dig in.
So let me just ask you this. When you're trying to figure something out, or maybe build something new, what's your go-to guide? Are you working from a perfect blueprint, a master plan designed from the top down? Or is it more like piecing together a fossil record, gathering bits of evidence from the bottom up to discover what's actually real?
And that brings us right to our core metaphor for today, the architect versus the archaeologist. The architect, well, they work top-down. They have a master plan, and they design a solution based on first principles. The archaeologist, on the other hand, works bottom-up. They discover truth by sifting through the evidence and learning from what's already there. One builds a solution, the other uncovers a reality.
All right, so let's see this clash of worlds play out in a couple of very different fields. First up, we're going to look at the fundamental code of life itself, and then the code that we write for our computers.
Our first stop is systems biology. Now, this is the field that tries to make sense of the ridiculously complex web of interactions happening inside every single one of our cells. Essentially, scientists here are trying to reverse engineer the machinery of life. No big deal, right?
So inside biology, you've got the architect's approach. This is pure engineering design. You start by defining a problem. Say, I want to create a cell that produces a certain kind of medicine. Then you put together a solution based on what you already know, you test it, and boom, you get a tangible outcome. You are literally building a biological solution from scratch.
And then you have the archaeologist's way of doing things. This is the classic scientific method we all learned in school. You observe how a cell already works, you come up with a hypothesis about its internal machinery, you run experiments to see if you're right, and then you tweak your ideas to better match reality. Here, you're not building, you are discovering what's already there.
There's a quote from the research that just nails this divide perfectly. Synthetic biologists build, and systems biologists model. One is the architect, right? Constructing brand new biological parts. The other is the archaeologist, creating models to understand the amazing system that nature already built.
Okay, now here's where it gets really interesting. If we jump from the biology lab straight into the world of software, we find the exact same pattern. It's the same fundamental tension, just expressed in code this time.
Let's make this super simple. Think about buying a movie ticket online. The architect, in this case the software developer, sees a nice, clean story. Seat selected, then payment received, and finally ticket issued. Simple. But the archaeologist, the data engineer, they see the raw evidence trail. The booking status was updated, then it was updated again, and then it was updated a third time. One view is the clean story we want to tell, the other is the messy reality of what actually happened in the data.
Okay, so we've seen this pattern in biology and software. But what happens when we try to apply it to something as messy and, well, human as morality? Let's take a look at how we're trying to teach our machines to be good.
When we get into building ethical AI, we are right back at that same fork in the road. Do we act like architects and try to program a strict set of moral rules from the top down? Or do we act more like archaeologists and create a system that can learn what's right from the bottom up through trial and error?
And this table lays it out beautifully. The architect's top-down path is all about theory. It relies on rule-based ethics. In practice, this means hard-coding rules, like you'd find in a basic chatbot. But the archaeologist's bottom-up path is all about experience. The method here is machine learning, where an AI figures things out as it goes.
But here's the catch with being a pure architect. As the research points out, the price of these top-down theories can be static definitions which fail to accommodate new conditions. The world is just too complex, and it's always changing. A rigid rulebook can get outdated or even become harmful in a heartbeat.
And the pattern just keeps going. Get this, it even shows up when we design an AI to actually be a scientist. So when an AI's job is to make new discoveries, how does it get its aha moments? Does it follow the architect's pre-written blueprint, or does it dig around for new evidence like an archaeologist?
Well, it turns out it needs both. Researchers are designing these systems with what they call a dual memory. On one hand, it has the architect's library, all the established structured knowledge of an entire scientific field, but it also has the archaeologist's field notes. its own unique learning path shaped by its own experiments and discoveries.
So, we've looked at biology, we've looked at software, and we've looked at AI. Now it is time for the big reveal. Let's pull all these different threads together and see this single, powerful pattern that's been hiding in plain sight this whole time.
And here it is. This is the payoff. In biology, the architect is engineering design, while the archaeologist is the scientific method. In software, it's the clean narrative versus the raw data. In AI ethics, it's top-down rules versus bottom-up learning. And for that AI scientist, it's the collective knowledge versus individual experience. Do you see it? It's the exact same pattern, playing out over and over and over again.
So the crucial point here is that this is not a coincidence. This duality, this back and forth between building from a plan and discovering from evidence, is a fundamental pattern in how we create and understand our world. It's woven into the very fabric of our cells, our code, and even our attempts to build a conscience.
Okay, so we've spotted the pattern. It's everywhere. But so what? Why does this actually matter? What's the real takeaway for how we should be tackling the huge problems of the future?
The answer, it turns out, in every single one of these cases, is not to choose a side. It's never architect or archaeologist. The most innovative, the most resilient, the most powerful solutions are always hybrids. They find a way to embrace both approaches at the very same time.
Just think about it for a second. The best bioengineers, they use their architectural models to guide their archaeological discoveries. The best software? It tells a crystal clear story that is actually grounded in the raw, messy data. A truly ethical AI will probably learn from experience, but within a smart framework of guiding rules. And the greatest scientists have always used the collective library of knowledge to guide their own unique dig for brand new truths.
And that, right there, is the real takeaway for you. This architect versus archaeologist idea isn't just a cool theory. It's a powerful mental model you can actually use. It's a new lens for looking at any complex problem you're facing, whether that's in your job, your studies, or just in life. So I'll just leave you with this question to chew on. As we all build our future, with AI, with genetic engineering, with technologies we can't even dream of yet, are we acting like architects, working from some grand master plan? Or are we more like archaeologists, carefully discovering what's possible, one piece of evidence at a time? Maybe the real secret is learning how to be both.